Hi, it's Miss Marsden. I'm going to take you through a lesson on estimating populations today. So what you need in front of you is you need the student booklet, and you might want to also have your notes open from the previous couple of weeks as well, especially the booklet from the food chains lesson, which was the first lesson that we did as part of this topic, as well as the impact on food webs lesson, which is what you completed last week. So make sure you have no distractions, make sure you have a pen and paper handy just in case. And your do now task is quite a long one. It's recapping the topic that we've covered so far. So it's just questions, for example, picking apart food chains from food webs. And I'm perfectly confident, based on the feedback that I've had from people completing last week's lesson, that we'll be absolutely fine completing this. So pause the video for as long as you need to be able to complete this task. I'd recommend spending about 15 minutes on it. I'm going to go through all of the answers as part of the next slide, and I'm also going to send the answers out within the answer booklet. The first question was asking you to pick out 3 individual food chains from the food web, and you could add any of the ones which are on the board now. Asking you to provide definitions from each one. If you struggled with the definitions, use this as a pointer for how you define each one in terms of providing the meaning, and cover up the examples. And using the definitions, you can go back and have a go. If you just want to check your answers for both, they're both on the board. I'll give you however long you need by pausing the video to improve it. You may also want to refer to a secondary consumer as an animal that hunts and kills the primary consumer. You may also refer to it as the third trophic level of a food chain as well, because it goes producer, primary consumer, secondary consumer. So this is linked to what you talked about last week in terms of the impact of various organisms on other organisms which exist within that food chain. And there are several options for each answer. So if you kill off a predator of an organism, for example, for question 1, the crab population would increase because there's no animal which is feeding on it any longer. So if nothing eats it, they're free to breed and they'll thrive. So just check your answer for 3B. It's quite straightforward based on what you did last lesson. If you really struggled with that, what I would do is I would get the link from the website to go back to last week's lesson, re-watch it, then have another go. We're going to be doing something completely different today, and we're going to be talking about estimating populations. So what you need to do by the end of the lesson is you need to be able to tell me how to make and record measurements to estimate a population of organisms in a given area. You need to be able to process those results and calculate them when necessary. And we're also going to talk about the fact that these are estimates and how we can make sure that we gain the most accurate estimates that we can. So we've got an image on the side, and actually, if we wanted to estimate how many dandelions there are in that field by counting them, it would be pretty difficult to say the least, because there's obviously thousands of them. And it's obviously not realistic to go into a field and to count every dandelion without losing count or being able to recognise which one you have and you haven't counted. So what we do instead is we use a different method, and that method is counting the numbers of species within a small section of a given area which we are sampling. For example, in that field, we'd take several different small samples of that area. And we do that using something called a quadrat, which I'm going to talk about in a minute. And a quadrat allows us to take multiple random small samples. Because we're taking multiple samples, we can then calculate the mean. And we use that mean to multiply across the whole area of our sample site, for example, the field, which I just showed you. So what is a quadrat? A quadrat is basically just a wire square, and we usually have them so they are 1 metre squared. So they're quite light, and effectively what we can do is we can throw those onto random areas of a field, and obviously because it's all the space in between the frame is free, we can count the individuals which fall within that frame. How do we use a quadrat to estimate populations? We first find the area of our site. So area, you need to measure the length and the width of your given site. You then times the length by the width to gain your area. So again, just make notes while I'm talking, keep pausing it if you need to, rewind it if you need to, that's absolutely fine. We also need to find the area of a quadrat. Again, length times width. But our quadrats are typically 1 metre squared. They have 1 metre either way. So on the length and the width, they are 1 metre long. So what we do is we can divide the area of the site. For example, if my site is 20 metres squared, we can divide that by the area of the quadrat, which we said was 1 metre squared. And that would tell me that my quadrat fits 20 times into that area. So 20 divided by 1 is 20. So that will give me something called my multiplication factor. What I then do is within my area, I place my quadrat randomly. And you can do that easiest way you can do it is just throwing it randomly. So you've thrown your quadrat, it's landed on a given space in the field, and you count the number of organisms within it. So if this example was dandelions, you count how many dandelions are in your quadrat. You repeat that 10 times. And obviously you take down your recording of the number of dandelions in each quadrat each time. What I can then do is I can work out the mean number of organisms in each quadrat. And how do you calculate the mean? Write this down if you don't know. You add together all the values and you divide them by the number of values that you have. So in this instance, I would divide it by 10. And what I then do is I multiply my mean number to estimate the total number in the site. So if my mean number per quadrat, let's say, is 20 dandelions, remember that the multiplication factor I worked out earlier was 20. So if I have 20 dandelions per quadrat and 20 quadrats that fit in my area, I just multiply them together and that will give me my estimate of 400 dandelions in my area, okay? So let's do an example together using some numbers. So this is my area that I want to take my samples from and to make an estimate for the number of organisms in this area. So I've got my length and width labelled, which are 35 and 12. So I'm using this time a quadrat, which is 0.5 metres by 0.5 metres. And these are the samples that I get from throwing my quadrat 10 times randomly onto this field. We're counting the numbers of daisies instead of dandelions. So remember, the first thing I need to do is to calculate the area of my site. So I do length times width, and that will give me my area, which is 420 metres squared. So that's your first step, calculate the area of the site. Now what I need to do is I need to calculate the area of my quadrat. So I do 0.5, which is the length, times by the width, which is also 0.5, and that gives me the area of the quadrat, which is 0.25 metres squared. So my next step is to work out the multiplication factor. So basically, how many times will my quadrat fit into my area? So I'm using my figure that I worked out, which is my area, which I got from length times the width. So I do 420, which is the area of my site. I divide that by the area of my quadrat, and that gives me this figure, which basically tells me how many times does my quadrat fit into my area, which is 1,680 times. So we need to remember that for later on after we've worked out our mean. So the next step, I need to work out the mean number of daisies in each quadrat, okay? So for this, I'm using these numbers here. So I add them all together and I divide by the number of figures that I have. So if I add them together, it gives me 45. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my mean number of daisies per quadrat is 4.5 daisies. So 4.5 daisies per quadrat. I need to remember that in my sample site, I can fit 1,680 quadrats. So my final thing to do is I need to do my mean, and I times that by my multiplier, which is in red. So mean times by the multiplier would be 4.5, and I times that by 1,680, and that will give me an estimate for my field of 7,560 daisies. So the takeaway from this is you calculate the area of the site first, then the area of your quadrat, then you divide the area of the site by your quadrat size, and that will give you your multiplier. So basically, how many times will the quadrat fit into your given area? You need to save that number for later, because what you do next is you work out the mean number of your organism per quadrat. You add together all the values and you divide it by how many you have. And that will give you your mean number, so your average. And then you use that average and you multiply it by your multiplier that you got earlier. So how many times does the quadrat fit into the field? You times that by your mean, and that will give you your estimate, which is your final step, just like this example, okay? So now we've done one together, so let's do an example together. So First step, we need to work out the area of the sampling site, and I'm going to let you do that. So your two figures are here. To work out the area of the sampling site, I'm just going to talk you through this. You're going to work out all the answers and we're going to go through them together next. The area of the quadrat's been given to you for step 2, so it's 0.5 metres squared. And now you need to work out your multiplier. So your answer for your area of the sampling site, so which is 12 times 10, and 12 times 10 gives you 120, and you divide that by your quadrat size, which is 0.5. So that gives you your multiplier, and you can save that number until after you've calculated the mean of your 10 samples. So add together all the samples and divide by the number that you have. You have 10. And what you now need to do is you need to take your answer you got earlier from 120 divided by 0.5. And then you multiply it by what you calculated for the mean. So you do your multiplier times by the mean, and that will give you your estimate. So, like I said, your area was 12 times 10, which gives you 120 metres squared. Your quadrat size was given for you, it was 0.5. So you do your area of your site divided by the area of your quadrat, which gives you 240. And we save that multiplier until we've calculated the mean. The mean number of thistles per quadrat, you should have done 15, which was adding all the figures together. And then you divide by 10 because we had 10 figures. And that should have given you 1.5. So what you then do is you multiply your multiplier, which was 240, by your mean number of thistles per quadrat, which was 1.5. And that gives us an estimate of 360 thistles in that area. So if you follow those steps, you can't go wrong in being able to estimate using your random sampling using a quadrat, okay? So there's some practice for you here. So it's split up into questions 1 and 2 for each one. And where it says at the bottom, multiply to give the number in the sample site, you need to separately do questions 1 and 2 because they link together. So question 1, you work out the area and you work out the mean, for example. And to work out the last question, you just do your area times by the mean, okay? So this is just some practice on how to calculate both the area and the mean. Pause for as long as you need to. I'm going to put the answers on the next slide. There's hints in the side box as always. Oh, answers. Area, the working out's done for you. You just do length times width. Mean, add them together, divide by the number you have. For the final question, you do area times mean, and the answers are at the bottom. I haven't included my answers for question 2 because they are very big numbers, but the calculations are there for you. So, how can we make our estimations more accurate? So we need to use bigger quadrats ideally. We need to take as many samples as possible. How many do we usually use? we usually use at least 10. That's why I'm using that magic number of 10. We also need to make sure it's random, okay? So in terms of throwing the quadrat, which is what we've been talking about, if you do it over your shoulders, for example, it means you're not looking for areas. If you're facing the area and you see a chunk with lots of dandelions, you're probably going to aim for there. So don't select the areas you're going to sample from. Do it completely random. So that's 3 ways you can make your estimates more accurate. And what I would like you to do is, there's an example on the video. This is completely optional, but it's just going to give you a chance to visualize what this whole looks like, okay? So I will post this in the work email for this week, and I will put it on the website also. This is completely optional. Watch the video, see how it's done. So the final task for today is I want you to be able to write up how we do this, okay? So we know how to do the calculations, great. I want to know that you can write up a method for how we can estimate the population of daisies in a field, okay? So include everything we've talked about in today's lesson. What I'm going to give you is some sentence starters, okay? There's a space in the booklet for you to do this. The sentence starters are also in your booklet. I'm going to go through the answers, so you need to pause the video for as long as you need to have a go at writing up your own method. Use the sentence starters to help you, please. I want you to check your answers, and this is basically, I've split it up into 2. I've split it up into your method and your calculations. So you measure and record the area. You randomly place your quadrat. Count the daisies in your quadrat and record it. And then you repeat that so you have at least 10 samples. We then need to complete the calculation steps, okay? So we calculate the area using length times width. We then calculate the area of our quadrat using length times width. We divide the sampling area, which is what you calculated for part A, by the area of the quadrat. And that tells us how many quadrats will fit into our sample area. That gives us our multiplier, and we don't need to use that until later. What we need to do first is we need to calculate the mean number of daisies in each quadrat. And then you multiply the mean by the answer you got for part C, which is your multiplier, and that'll give you your estimate. So if you didn't quite get that, use a different colour pen to improve your answers. And that's everything we need to do for this lesson. So what you need to do is you need to send your completed booklet back to your teacher, and you need to make sure you've completed your Educate quiz by Monday at 8 AM, please. If you do have any questions, please get in touch with your class teacher and they'll be happy to help you.